Hello, good morning to everybody. This is Mukherjee, working as Associate Professor in St. Peter's Engineering College. Today, we are going to discuss about helium neon laser. Now, coming back, a laser anyway, that is a device which emits light to this stimulated emitted radiation, after which a sufficient amplification laser is produced. And there are anyway different types of lasers like solid state laser, liquid laser, gas laser, plasma laser. And solid state laser, best example is ruby laser, a combination of aluminum and chromium. Gas laser, combination of helium and neon laser. So today we are going to discuss about gas laser, helium and neon laser. Why should we require a helium neon laser? Earlier, ruby laser, which is a solid state laser and also called as a 3-level laser, had some disadvantages. The first thing is the laser is not continuous. It is in the form of pulses, and very high power pumping source is required, and very low efficiency is obtained. That is the reason why we need to search for an alternative, and that alternative to some extent is given by helium neon laser. So let us see the helium neon laser. It was actually invented by Iranian physicist Ali and Bennett in 1960. So these two are being contributed for the development of helium neon laser. And the construction of helium neon laser is, here you're going to have a mixture of helium and neon. For 10 parts of helium, 1 part of neon is added, which is a gaseous mixture, is enclosed in an evacuated chamber, which is connected to a very high potential battery or source. Once again, lasing is always done by the impurities. Here the neon is going to do the impurity, being the impurity is going to produce the lasing action. But neon individually doesn't have the capacity to produce a laser, neither helium doesn't have the capacity to produce the laser. A combination of helium and neon at the combination of 10:1 parts, the helium first absorbs energy, gets excited, comes down to the ground state, immediately transfers energy to the neon. Neon absorbs the energy, goes to the excited state, moves to the metastable state and stays there till the number of neon in the excited is greater than the number of neon in the ground state. When such a state is reached, all the neon will come down to the ground state, producing beautiful stimulated emitted radiation. So the best parts of this helium neon laser are, we are going to have an evacuated chamber with helium neon composition, this and this is locked in an capillary tube or even evacuated chamber through which the electrical discharge is passed, and this is done by using electric generator between cathode and anode, and this gas chamber is locked between the reflectors, one being completely polished, the other being partially polished. In this laser, the active medium is the mixture of helium and neon. Now in 3-level laser, the parent atom get excited, comes down to the ground state, transfers energy to the impurity atom, and this impurity atom moves from ground state to the excited state. From there it slides to metastable state and stays there. After population inversion, it returns to the ground state, producing a beautiful stimulated emitted radiation. This is generally a 3-level laser, but it has one major drawback. The major drawback is that the photon which is responsible for this laser action can also induce absorption in the whole process, which may decrease the efficiency of the stimulated emitted radiation. Henceforth, we are going to go for a 4-level laser, and this is the working of helium neon laser band diagram. So let us see. Initially, the energy is given to the helium atoms. Immediately they get excited to the higher levels. Immediately they come down to the ground state. While coming down to the ground state, they transfer energy to the neon atoms. Now these neon atoms, they move to different excited states. It can be an upper laser level or a lower laser level. There are two different possibilities of the excited levels for the neon atoms depending upon the energy that is given to the helium. And this is the band diagram. So here what is happening? Energy is given from helium to neon, and neon moves from ground state to the excited state, and thereafter it moves to the two different short-lived states. The topmost short-lived state, from which immediately fast decay happens and the atoms move to the metastable state. From there, immediately they are not going to the ground state, they go to the second short-lived state, producing lasing transition. So one frequency of energy is produced. Once again, when the atoms are going to deposit here and the population inversion is achieved, from the second short-lived state, all the atoms return to the ground state, producing another fast decay, producing a beautiful stimulated emission radiation. And this is a 4-level laser. And here, what are the other construction details? Helium and neon are in the ratio of 10:1 at the pressure of 1 torr. And due to electric discharge, helium atom collides with the electrons, get excited at an energy of 20.61 electron volts. And these helium, they transfer their energy to neons. And due to spontaneous emission, the neon atoms moves to the metastable state. And from metastable state 2, stimulated emission happens and falls down to the metastable 1. And once again from metastable 1 to ground state, another transition happens. And the laser light produced by a helium neon laser is very dense and is continuous, of course non-pulsating and unidirectional. So what are things which we need to remember in this? It's a 4 energy state. Metastable state is very near to the ordinary excited state and ground state. Lifetime of the second metastable state is longer to produce a beautiful population inversion, and the lifetime of metastable state is very short to get depopulated to avoid reabsorption. And the purpose of having helium neon laser is to help to produce the population inversion in neon atoms. And in comparison, this is the comparison of a 3-level and 4-level energy diagram. In 3-level energy level, the atoms are getting excited and they are moving to the metastable. From that metastable, they are coming to the ground state, which is nothing but only 2 levels are possible. But in a 4-level, they are going to move to upper level metastable, lower level metastable, producing 2 different kinds of frequencies according to the requirement. And the characteristic, the light is very extremely monochromatic with 632.8 nanometers, which is highly temporal coherence light. Light is unidirectional, aligned, and this light is spatially coherent. And helium neon lasers are used in many fields by producing many colleges, schools, or educational types use the lasers in science programs for supermarket QR codes and barcodes, for alignment tool, and also used for guns. And what are the advantages of helium neon laser? They are used in guns for targeting like laser guided missiles, and they are also used to provide inherent safety. Helium laser tube is very small, approximately 10 to 100 centimeters, and the lifetime is approximately of 20,000 hours. And what are the disadvantages of helium neon laser? It is relatively low power device. The output which is produced is very low in comparison to the high output which is produced by a ruby laser. And helium neon laser is having a low gain, and it requires a very high voltage, which is also another disadvantage. And the escaping of gas from laser plasma tube makes us a little disadvantageous for having this helium neon laser. With this, we'll end this helium neon laser. Thank you. Jai Chitta.